October is Fire Safety Month, and as you know, we're doing a multi-part series on fire-related activities. This week, we're going to cover how to pick a UL firestop system, how to decipher that UL number, and how do you pick a firestop system for both regular and irregular openings. It's going to be a jam-packed show. Welcome to the show where we tackle tough questions submitted by installers, project managers, estimators, IT personnel, and even customers. On this show, we're connecting at the human level so that we can connect the world. If you're watching this podcast on YouTube and you like this content, would you mind consider hitting the subscribe button, and don't forget to hit that bell button so that way when new content's being produced, you'll get notified when it's being published. Any show notes will be in the section down below. If you're listening to us on one of the podcast platforms like iTunes, Stitchers, or one of the other platforms, would you mind consider leaving us a rating? Hopefully it's a 5-star rating. If it's not, email me and tell me what I could do better to make the show a 5-star podcast. Those 2 little steps helps us take on the algorithm so that we can educate, encourage, and enrich the lives of more people in the industry. Also, make sure you catch our live after hours multi-stream broadcast where I answer your questions live on YouTube, LinkedIn, Facebook. It's held Thursday nights at 6 p.m. Eastern Standard Time, except for when we're having hurricanes. Questions submitted early via comments or direct message or maybe even emails at questions@letstalkcabling.com. Obviously, we're going to get a preference. And finally, while we provide this content free of charge, and we always will provide it free of charge, if you would like to support this channel and have access to additional information, would you mind checking out our QR code on the screen right now where you can buy me a cup of coffee? I'll give you some free stickers if you do. Or you can even schedule a one-on-one 15-minute Zoom call with me, after hours, of course. You can also become a Patreon member where you can enjoy additional benefits and visit our Amazon links on our website to see some products that I like to use in the ICT industry. And if you buy them, you won't pay any extra, but I will get a little stipend off that if you do. Those couple little steps helps us pay for the stuff needed to broadcast this podcast. And finally, we are accepting applications for corporate sponsorship. So if you would like to help support our mission, again, to educate, encourage, and enrich the lives of people in the ICT industry, and you think it matches up with your mission statement, reach out to me through one of my social media platforms or via the email at chuck@letstalkcabling.com. So as you can tell, I'm still running behind because of Hurricane Ian. We had lots of cleanup to do, and then I also had to prepare for a road trip. So I hope you don't mind that this episode is just a few days late. Better late than never, right? Also, as you can tell, I am not in my home studio. This week I am broadcasting remotely from Baltimore, Maryland. I am visiting my mom and my sisters. And as you can tell, I have the dogs with me. So you may hear them, shake their head or rattle or whatever during the show. I apologize for that. But they're in here with me watching Dad make a show. October is Fire Safety Month. And specifically the week that just passed, October 9th, is National Fire Prevention Week. Now during this time, we should spend time to raise awareness on what we can do to limit the loss of life, what we can do to limit the damage to property, what we can do to raise awareness to professionals in the ICT industry, because this is a life safety issue. Now, the first thing I want to cover is why is it important to use a listed system? Why can't you just use mud and put a little bit of red dye? Why does it have to be a listed system? And what exactly is a listed system? So fire stops are listed. And in order to understand what that means, we have to go look up in the code book. Now, in the code book, Article 100 is the definition section of the code book. So if you go look up the word listed, you'll see that it's defined as, and I'm paraphrasing here because I don't have this committed to memory, but it's basically going to say a product or a service that has been tested by an NRTL, a nationally recognized testing laboratory, and that it meets the flame and smoke test standards set out by the NFPA and is accepted by the authority having jurisdiction to be installed in buildings in their areas. Some examples of some NRTLs, some nationally recognized testing laboratories, would be UL, Underwriters Laboratories, Intertech, ULC, Underwriters Laboratory Canada, and there's a few others as well. So they're the ones who will test that product. When a manufacturer wants to design a new firestop system, their engineers are going to design them for a specific application and for specific ratings. For example, if they have a new firestop system that they want to design for some new type of cable, like a Cat 15 cable, the engineers are going to conduct their calculations based on the design of that cable, what it's made out of. They will build a sample assembly, and then they're going to send that assembly to the NRTL to be tested. Now, the NRTL has a specific laboratories where there's actually a really good video on this. If you go to YouTube and you type in the search bar IFC &UL firestop, you're going to find a video on how they actually test these systems. Pretty cool. So if they design that system for a 2-hour rated system, they're going to put it in that burn box and they're going to burn it for 2 hours. Now, there are some additional tests that are required based on what region this is done in, and this is not a cheap process. Some of the firestop manufacturers, like Hilti, have their own testing facilities. Some common additional classifications you'll see will be flame, temperature, leakage, and water, just to name a few. There are some others, but those are the more common ones. In that flame test, you're going to see in that video, if you decide to go watch it, that they literally will put a firestop system in a wall and they expose one side of that firestop assembly to direct flame. And the assembly is rated on the amount of time that it resists flame passage, and that time is expressed in hours. Now, some standard organizations require some additional host stream tests, while other organizations don't require the host stream test. This is the one important reason that you need to know the rating of the wall or the floor that you're going to be penetrating so that you can pick the right system. Now, the temperature test is a little different. They're going to measure how long it takes the side of the firestop in the unexposed room to reach 358 degrees Fahrenheit, or for my people outside the US, 181 degrees Celsius, above ambient temperature. Let me dive into that a little bit. If you have two adjoining rooms and there's a firestop that penetrates a wall that connects those two rooms together, and a fire breaks out in one of those rooms, all the heat and the flame are going to be directly exposed to that firestop assembly in that exposed room. The temperature can range between 600 and 1500 degrees depending on the contents of the room. And remember, as we learned in last week's episode, fire spreads through conduction, convection, and radiation. And if you missed that episode, I suggest you go back and listen to it. Now, let's say the ambient temperature in the adjoining room, the unexposed room, is 72 degrees. That's what ambient means. It's normal temperature. So it's 72 degrees. They're going to measure how long it takes for the temperature in the unexposed room to reach 430 degrees. Now, you're probably wondering, 430, that doesn't make sense. It's 72 degrees plus the 358 degrees per the testing standard, and that equals 430 degrees. Now, at this point, things in the non-fire room can actually start burning, especially if they've reached their auto ignition points. Remember, last week we talked about auto ignition point, and I told you that newspaper, the auto ignition point, is right about 450 degrees, where if it's heated up, it will just catch on fire. Now, the amount of time it takes for the non-fire room to reach that 358 degrees above the ambient temperature is expressed in hours. Now, I did mention the host stream test, and I wasn't going to talk about it, but it is required by some of the testing standard organizations and not by some others. The host stream itself test is connected. The host stream test is conducted within 10 minutes of them finishing burning the assembly. So what they're going to do is they're going to take a hose that measures 2.5 inches or 64 millimeters. They're going to put a nozzle on that hose. That nozzle will be a 1.125 nozzle. And they're going to spray water at that firestop assembly from a distance of about 20 feet, or a little over 6 meters. They will shoot water directly at the head on that firestop assembly, and also from the transverse side, moving the water up and down. Although in the meantime, while they're doing that, there's going to be somebody on the other side of that firestop assembly looking to see that no water is allowed to pass through that fire stop system. And if no water is observed, then it passes the hose stream test. Next is the leakage test. The leakage test measures if air passes through the assembly, and it's measured at 2 points, at ambient temperature as well as elevated temperatures. Now, they usually use this test to mimic smoke passing through a fire stop assembly. Smoke is dangerous. It's more dangerous than fire. It is the number one cause of death in a building fire. I gave you some statistics in last week's show. When smoke is contained, then that's going to allow the occupants of the building more time to escape out of the burning building. It's going to make it easier also for the firefighters to do their job because they're going to be able to see where they're going. They're going to be able to see the fire that they're going to be fighting. The next test, the water test, is where the fire stop assembly is subjected to 3 feet of water for 72 hours. Now, this is important because with floor penetrations, when the fire department puts out the fire, water will stand on that floor until it gets cleaned up by somebody. And you don't want that water going through the floors below and damaging the floors that did not have the fire. So it subjects that fire stop column to a 3-foot column of water for 72 hours. Now, once the fire stop passes all the required tests, then it's going to be issued a UL drawing number. On that UL drawing, it's going to tell you how deep the putty has to be, if you have to use, or how deep the caulk might have to be. It's also going to tell you if you need any ancillary items like mineral wool. It's going to tell you if you have to have minimum or maximum annular distances for the assembly. Make sure you follow that UL drawing step by step by step. That's important. Your fire stop assembly has to be installed exactly as the UL drawing indicates because that's how it was tested. Any variance from the design, you will nullify your listing. And you don't want to nullify that listing. Trust me. This is why you cannot mix and match fire stop products as they haven't been tested that way, right? If your assembly in any other manner than UL drawing stipulates, you could have a potential code violation. And if people or property are hurt or damaged, you could potentially be held legally, criminally, and financially responsible. So make sure you install it per the UL drawings. Let that sink in for a minute. You got to install it or you're going to be held responsible. Because of the listings, there's some of the things you need to be aware of. For example, if you have a 2-hour rated system that you just installed and you want to increase it to a 4-hour rated system, you can't just add putty to it. And vice versa. You can't cut it in half either. If you change the type of the fire stop, the location, or even add to that system, you might also have to change the fire stop system so that way it maintains its ratings. Okay, these are not just plug and play stuff. And also, you can't use drywall mud with red ink. So let's now move the conversation to how to decipher that UL drawing number. I went onto the website and found a UL drawing to use for this. And I couldn't really find a good one, so I'm just going to randomly generate one, and we're going to show you how to decipher it. Now, the people who are watching this on YouTube, you're going to see some charts pop up as I'm going through this. Those of you listening on the podcast, if you want to see those charts, you're going to have to go to the YouTube video. So let's say that our fire stop system is WL3100. Let's figure out how to do that. Well, the first letter of that WL3100 tells us if it's rated for a floor, a wall, or a combination. Since ours is a W, it's a wall. If it's a C, then it's a combination, right? If it's an F, then that system's designed for floors. So you can tell immediately if there's an F system installed in the floor, then you know there's a problem there because it's actually a floor fire stop, not a combination or a wall fire stop. Our second digit is going to be L, because remember it's WL3100. The L tells us what is it that we are penetrating, right? The L indicates that it's a framed wall. There are some other indicators as well. They use the alphabet letters A through Z. N and Z are reserved for future use. Had it been a letter B, then that fire stop system would have been rated for a concrete floor with more than 5-inch thick flooring. So that second digit tells you exactly what it is that you're penetrating. Now comes the 4 numbers at the end of that WL3100. That first digit of that 4-digit number, the 3, tells us that that fire stop system is for electrical cabling, right? If it had been a metal pipe or conduit, then that digit would have been a 1. And then the 3 remaining digits are just the unique identifier for that specific system. Now you're probably wondering, well, why is this really important to me? Right? If you know this system, it's going to help you as an installer because you'll be able to look at that. And if the estimator gave you a firestop system began with an F, which is for floors, to use for a wall, then you know that they're giving you the wrong system, right? Or if the second letter was an A, then that meant that the concrete floor was less than 5 inches where you measured your floor, and it was more than 5 inches. So it can help you identify without even having access to the catalog if you know how to use that system. As a designer or a RCDD, you can verify the customer or the firestop manufacturer if they have chosen the right system for your project because you know how to decipher that system. Trust me, it's easier to fix a wrong firestop before you install it, not after you install it. What if you get asked to pick a firestop system? How do you select that system? How do you know that it's going to work? Well, you can contact your local sales rep or your firestop manufacturer. They will help you select the right system. But sometimes that's not the most efficient time-wise. The sales rep might not be available. The manufacturer may not be returning your calls. Hilti and some other ones, they actually have some selection processes that you can go through and pick the right system. Some of them do it in their catalog. Hilti even has an app, and it walks you through the process. There are 6 things that you need to know in order to select the right kind of system. They even are kind of lined up with the UL drawing numbering system that we just kind of deciphered. So it kind of all rolls together and works as one. First, you're going to need to know what is the system that you're going to be penetrating. Is it a floor or is it a wall? Okay? These systems are different in how they are made, they're different in how they are tested, and they're different on how they are installed. That's why that's important. The second you need to know is what was that floor or wall constructed of? Is it a floor? How thick is the concrete? Is there a metal pan underneath the concrete floor? If it's a wall penetration, is that wall made up of gypsum board? What kind of studs are inside of it? Are the studs wood? Are the studs metal? Right? Is the wall also made up of concrete blocks or cinder blocks? Those are all things you need to know to decipher and get the right one. The third thing you're going to need to know is what will be penetrating that wall. Is it going to be 4-pair cable? Is it going to be backbone cable? Is it going to be interduct? Is it going to be fiber cable? Is it going to be a conduit? The fourth thing you're going to need to know is what is the diameter of all of the penetrating items? How many Cat 5e cables? How many Cat 6a cables? What are the diameters of those cables? Will there be any fiber cables? And based on those numbers, you can calculate the overall diameter of everything combined. And if you're not good at math, again, the firestop manufacturers have fill ratio calculators that you can use to figure out if it will all fit in their system and still work. So you don't have to be good at math. You just got to know your resources. Fifth, what is the rating of the assembly? Is it a 2-hour rated assembly, a 3 or a 4-hour rated assembly? Whatever that assembly is rated, your system has to match or exceed that rating. If you have a gypsum board wall that's 5/8 thick, type X sheets, each sheet is rated to 1-hour fire rating. So if you have a wall that has a sheet on each side, then it's a 2-hour rated wall. A 1/2-inch gypsum board gives you 30 minutes of fire rating. Now, many new buildings, the GC will have the fire ratings painted on the wall so all the trades know what is the rating so that they can select the correct kind of firestop system. This has become such an issue that many GCs will now tell their subcontractors on the job site not to install fire stopping. And this is because the GC has hired a separate fire stopping contractor to come behind everybody and seal up all the penetrations. This is a huge benefit for the GC because now they know that all of the fire stop holes will be done correctly and they're going to be all installed by somebody who has attended some kind of fire stop training. They're qualified to do this, as opposed to some trades who may not be trained on how to install fire stop systems. The sixth and final thing that you're going to need to know is there going to be any movement or any kind of environmental exposure? Vibration could cause big problems with fire stopping because it breaks that seal. Once you have all this information, And the selection process is pretty straightforward. You just kind of work your way through it, whether it's the app that Hilti has or in the catalogs. With all that information, you'll be able to walk right through it and pick the specific system for your application. You may come across a situation where you cannot find a specific system for your application. In those situations, you can contact the manufacturer, the firestop manufacturer. You can get what's called an engineering judgment. Now, be prepared to answer a lot of questions. You may also have to submit pictures. You may also have to submit drawings. And they got to be the latest version of the drawings. The engineer can select the right system for you or design the system for you, and you can put it in, and that's the same thing as having a listed system. The risks are just too high to just wing it. Okay, do it right. This is somebody's life you're talking about. If nothing else, maybe it will inspire you to get some firestop training if you haven't already. Maybe I might do that in the next show, whether you can get firestop training. Because remember, knowledge is power.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.